working out a confidence interval for the population proportion P using a normal approximation. We will use a normal approximation to the binomial distribution with an estimated standard deviation. Because we're estimating the standard deviation, what we're calculating is an approximate confidence interval and not an exact confidence interval. The first step is to calculate a value called p hat. This is the proportion of successes in a given sample. So you take the number of successes and you divide it by the total number in the sample. The hat represents an estimated value. We're using this to estimate the population value. The p hat value calculated then feeds into this formula. This formula is used to calculate the confidence interval. It's not given in the AQA formula book, it needs to be memorized. And the p hat value calculated there goes in these three places in the formula. N is the total number in the sample. That value goes there. And this plus or minus Z is from the tables. And it's obviously the normal distribution. In this example, 400 is the total number in the sample. So that value goes here. And it's N. So this is 400 here and here. The number of successes is 186. That value goes here. So by dividing, we now have p hat. And p hat goes here, here, and here. So we still have to work out Z. For a 90% confidence interval, we put 90% in the center of the normal distribution, 5% in each tail. The cumulative probability to the left of this line is 95%. We look up p equals 0.95 from the tables, and we get a Z value of plus or minus 1.6449. There's p equals 0.95, and here's the Z value. So p hat is 0.465. Putting everything into the formula, calculating the minus value first, 0.424, and then calculating with the plus, 0.506. So there's a 90% chance the true population proportion lies in between these values. There's a 10% chance the proportion is outside these values. Two reasons why the confidence interval that we just calculated is approximate. The first one, the normal distribution, is used as an approximation to the binomial. So we're not using the exact binomial distribution, so we have an approximate confidence interval. And secondly, the standard deviation used is an estimate. And the standard deviation is this part of the formula. Or this value in our calculation. This is the estimated standard deviation.